Imagine a cat, both alive and dead, locked inside a sealed box. How is that possible? This isn't magic, it's quantum mechanics, and it turns our very notion of reality upside down. In 1935, physicist Erwin Schrödinger introduced his famed cat thought experiment to illustrate a core concept: superposition. In the quantum realm, a particle, like an electron or an atom, doesn't exist in one definite state until it is observed. Instead, it simultaneously occupies all possible states. To simplify, imagine a dark room with a light bulb. Until you flip the switch, you don't know whether it's hot or cold. Quantum physics says it's both hot and cold at once until observation. Here, the bulb pawns the radioactive particle. Hot pawns decayed state. Cold pawns intact state. As long as the box stays closed, the particle exists in both states, and so does the cat. The moment you open the box is the quantum measurement. It forces the particle to choose a single state. Either decayed, the cat is dead, or intact, the cat is alive. Picture a cloud. Droplets float freely until you toss a net, corralling them into one basket. That's wave function collapse. Without measurement, no fixed reality. With measurement, superposition collapses into one outcome. You might think, no way a cat can be both alive and dead. That's exactly Schrödinger's point. But decoherence explains why we never see a superposed cat. Inside the box, the particle constantly interacts with air molecules, photons, and other particles. These tiny exchanges measure the particle's state even before we open the box. In less than a billionth of a second, superposition vanishes and only one state remains. Result? Even without a human observer, the environment measures the particle for you. To understand better, imagine a vector graphic on your computer. Before exporting, it contains all possibilities: layers, paths, editable shapes. Once you save it as a PNG, you get one fixed image: vector file, superposed state, PNG, collapsed state. Another analogy, a Netflix movie. Until you hit play, it lives in the cloud of possibilities. When you press play, a single stream materializes. These visuals simplify how a quantum system goes from many to one. Even though decoherence handles the practical side, the philosophical shock remains. Is collapse real or just apparent? Copenhagen interpretation. Reality exists only upon observation. Many worlds theory. With every measurement, the universe splits into parallel realities. One where the cat lives, another where it dies. Think about it. Infinite universes coexist, each with its own version of you and your cat. Conclusion. Schrödinger's cat isn't just a quirky puzzle. It challenges how we define reality and our role as observers. Shift your perspective, and the quantum world goes from intimidating to awe-inspiring. Open the box, share this video, and let your friends discover that reality is what you create by watching it. And you, which quantum theory gives you goosebumps? Copenhagen or many worlds? Let us know in the comments. What GIF best captures your reaction when you finally grasp wave function collapse?